In the world around us, nothing truly works alone. A school works because teachers, students, and classrooms are connected. A business works because customers' orders, payments, and services interact together. Even the technology we use every day is built from systems filled with connected components. Programming works the same way. Objects are powerful on their own, but when objects begin to work together, they create intelligent systems. Think about a classroom. A student is connected to a classroom. A teacher is connected to students. And learning happens because these relationships exist. Or think about online shopping. A customer places an order. The payment system processes the transaction. The warehouse prepares the product, and the delivery service sends it to your home. No single object can handle everything alone. Systems become meaningful when objects collaborate. In object-oriented programming, we model these real-world relationships inside code. Objects can know about each other. They can exchange data, call methods, share responsibilities, and work together to complete tasks. This is where software begins to feel alive. Not because of individual objects, but because of the connections between them.
One of the most important relationships in OOP is called association. Association describes a connection between objects. For example, a student can be associated with a classroom. A customer can be associated with an order. These objects know about each other and can interact together. But importantly, they can still exist independently. Association creates communication without strong ownership. Once objects are connected, they can begin to interact. One object may call a method from another object. Data can be passed between them, and together they complete a process. Imagine ordering coffee in a cafe. The customer places an order. The barista receives the request. The coffee is prepared and the result is delivered back to the customer. This interaction is very similar to how objects communicate in software systems. Objects don't just store data, they collaborate. Some relationships are stronger than simple association. One example is aggregation. Aggregation describes a whole and part relationship where the parts can still exist independently. Think about a team and its players. A team contains players, but players can still exist even if the team is gone. Or think about a library and its books. Books may belong to a library, but books can still exist somewhere else. Aggregation gives us flexibility. It allows objects to be shared, reused, and connected without permanent ownership. Now, let's look at a stronger relationship called composition. Composition is also a whole and part relationship, but this time the parts cannot exist without the whole. Think about a house and its rooms. If the house is destroyed, the rooms no longer exist as part of that house. Or think about a human body and its heart. The heart depends completely on the body. Composition represents strong ownership, strong dependency, and tightly connected life cycles. This helps software become more organized, stable, and reliable. At first glance, association, aggregation, and composition may look similar, but their responsibilities are very different. Association is simply a connection between objects. Aggregation represents a shared relationship where parts can still live independently. And composition represents strong ownership, where parts depend entirely on the whole. Choosing the right relationship helps software become clearer, more flexible, and easier to maintain. In modern software engineering, relationships are everywhere. Large systems are not built from one giant object. Instead, they're built from many smaller objects working together with clear responsibilities. This allows systems to grow over time. New features can be added, components can be improved, and different services can evolve independently. Good relationships create software that is modular, reusable, maintainable, and scalable. That is why object relationships are so important in software architecture. When we step back and look at the bigger picture, we begin to realize something important. Programming's not only about writing code. It is about designing relationships. Objects represent ideas, relationships represent cooperation, and systems become powerful when every part works together toward a purpose. Just like people in the real world, software becomes stronger through meaningful connections. Great systems are not built by isolated components. They are built through collaboration. Behind every great application, every smart platform, and every modern technology, there are objects working together, connection by connection, relationship by relationship. Association, aggregation, and composition are more than programming concepts. They teach us how systems grow, how structure creates stability, and how collaboration creates possibilities. Objects alone can create programs, but connected objects create intelligent systems. So keep learning, keep building, keep connecting ideas. Because the future of technology will always belong to those who know how to create meaningful systems. And your journey is only beginning.